You might not think of water as being magnetic, but it is, and so are graphite, aluminum, and glass. This is a new and different category of magnetism called either para or diamagnetism, and it's different from the magnetism that you're used to. You're probably already familiar with ferromagnetism. Ferro means iron. An unmagnetized piece of iron, or nickel, or cobalt, becomes a magnet in the presence of a magnetic field. The effect is strong and lasts even after the magnet is removed. Paramagnetism is a similar effect, except that it's much weaker and temporary. Aluminum is a good example of a paramagnet. And so is oxygen, which is attracted to magnets. Here, I have a few milliliters of liquid oxygen which sticks to the magnet. I'll explain why later. Gadolinium oxide and cupric sulfate are good examples of paramagnetic substances. Cupric sulfate is a salt that can be picked up by a magnet. Diamagnetic materials are exactly the opposite of paramagnetic. They are always repulsed. They would rather die than be in a magnetic field. An important example of a diamagnetic material is graphite. This specially made pyrolytic graphite is repelled by a magnetic field. Don't be confused. This is not static electricity or eddy currents. Graphite is repelled by a magnet, always, both by the north and south end. Pyrolytic graphite is a grown crystal of flat carbon layers which maximizes the diamagnetic effect. Of course, the best diamagnets are superconductors, which at low temperatures provide exact opposite repulsion to whatever magnetic field is present when they're chilled. They are perfect diamagnets. The most famous and powerful diamagnetic is bismuth, element number 83 on the periodic table. The bismuth-powered boat sails toward the weaker magnetic fields. One way to check whether an object is diamagnetic or paramagnetic is to see how it aligns itself in a magnetic field. Diamagnetic objects like glass will rotate to avoid magnets. Here, we see that the glass is diamagnetic because it twists to get to the weaker magnetic field. But aluminum rotates into the field, typical of a parallel paramagnet. On the periodic table, we see that aluminum has 3 valence electrons. So what does it take to understand what it means for something to be a paramagnet or a diamagnet? You have to know what the electrons are doing. Consider, for example, aluminum. We see from the periodic table that aluminum has 3 valence electrons. That's 2s and 1p. Now it's that unpaired electron that makes it a paramagnet. This unpaired electron enables it to become magnetized. And it's that unpaired electron that is free to be magnetized and attracted by the magnet. But what about a diamagnet, like water? Yes, the water molecule. It has all of its electrons paired. It will not be magnetized. In fact, water is repelled by a magnetic field. The electrons come to lower energy as they are moved away from the magnet. In conclusion, when something is a paramagnet or a diamagnet, it tells you what its electrons are doing. In the case of a paramagnet, it has at least 1 unpaired electron. In the case of a diamagnet, it has mostly paired electrons.